As we have seen, to be a data scientist, two things are required. Let's say statistics and machine learning. Statistics and machine learning. Now, for now, we are not discussing about machine learning. We will come to that. Now, if I divide this further bifurcation, if we do, so we can divide the whole mathematics part into two categories. So here we can say statistics plus linear algebra plus probability. These things we have to know. So once we know these things, then their application, whatever we are going to learn here, statistics, linear algebra, probability, then we are going to apply all of them into machine learning. And this, with the help of machine learning, we are going to get some prediction. So it is going to help us with some prediction, or you can say the predictive analysis. So first of all, we will see in statistics, we will go with the linear algebra, then we will go with the probability, then we will learn statistics, and after that we will see their application in machine learning. So let's start with the first part, and that is the linear algebra. So linear algebra is a branch of mathematics that deals with linear equations. Linear algebra, what is it? It is a branch of mathematics. It is a branch of mathematics that deals with linear equations. With linear equations. So linear equations are in the form of, we can say, y equal to mx plus b. So this kind of structure, whenever we have this kind of equation, whenever we have this kind of equation, we call it as the linear equation. Now, if we solve the linear equation, so it is when we perform operations on the linear equation, it falls in the category of linear algebra, we can say. Now, what is the use of it? Why do we need the linear algebra? That is the question. Now, let's go back to 10th or 12th standard, and there we used to have some problems like this. For example, we used to say x plus y equal to 10. We used to have some equations like this. Then we may say 2x minus 4y equal to 16 kind of thing. And then we used to solve some solution we used to do, right? We used to solve such equations. Let's say this is equation 1 and this is equation 2. So something similar we are going to do here itself. Now, what is the use of linear algebra here? Now, tomorrow, when we are going to play with the data is going to come in the tabular format like this. So the data that we are going to have is going to look like this. Let's say I have some variable age. Then I have some variable, for example, income. Then I have some variable, let's say, education. And then I have some result. I have some result, and the result has some value. So let's say it says age is 25, income is 7 LPA, education is, let's say, graduate, and graduate I am representing by 1, and the result says he this this person is eligible for some loan. Let's say result for, you can say, the result is loan amount, and this person is eligible for 2 lakhs of loan. Now again we may say the education age is maybe 29, income is 5 LPA, education I am saying is 2, let's say he's a postgraduate and he's eligible for, let's say, 1.8 8 lakhs of loan. So if I see this, so here we can say this is nothing but x plus y plus z, and equal to this is some value. So it is going to happen like this: 25x plus 7y plus z equal to 2. Then we may say 29x plus 5y plus 2z equal to 1.8, something like this. So we can say equation 1, we can say equation 2. What I'm trying to say is the data that we have in the tabular format, when we are going to feed it to some ML algorithm, machine learning algorithm. Now this machine learning algorithm is nothing but a mathematical function, and internally it is going to express this in the form of some linear equations like this, and it will be solving them. So that is the reason if I want to know the functionality of a particular machine learning algorithm, how it is working, how it is learning the pattern from the data, for that we need to know how linear algebra or the linear equations we work upon. Fine. Now to solve the linear equations, there are multiple methods. The one method is the normal mathematics method, okay, that we used in our school days. So if I have, let's say, x plus y equal to 10, and I say 2x minus 3y equal to let's say 15, whatever. So in this case, what we can do to solve this one method, I can say divide the multiply equation 1 by 2, so it will be 2x plus 2y equal to 20, and then I will say 2x minus 3y equal to 15, and then I use the negative sign here like this, it will cross, it will be 5y and equal to 5. So here I can say y equal to 1. If I put the value of I into any equation, so x plus 1 will be 10, and like this we can say x equal to 9. So this is the method we solve. This is one method to solve linear equations. The another method to solve linear equation is using matrices. So we can solve linear equations linear equations using matrix. So matrix, what we do, if I have the same equation, let's say x plus y equal to 10 to x minus 3y equal to 15. So these equation are there, x plus y equal to 10, 2x minus 3y equal to 15. Now these two equations I can represent in the form of a matrix like this. I will take the coefficient, let's say 1, 1, 2 and minus 3. This is one matrix. Then I will say, and here I will be having the coefficient x and y, two coefficients I have, two variables equal to 10 and 15 like this. So we represent it like this. So we will see in this section how to solve linear equations using the matrix operations, guys. Now why we are learning matrices, the algorithms that we are going to use. So internally it is going to use the matrix operations, or you can say the matrix calculations, to solve the linear equations. Once we know how to solve them using matrices, we will be able to understand how the machine learning algorithm is learning internally, and we will be diving deeper into them. Fine. So let's start our topic, and the topic is, we can say, the topic that we are going to do is the matrix. So we are going to start with the matrices here. What is a matrix? So to understand matrix, we can say when we represent when we represent numbers when we represent numbers in the form of rows and columns enclosed enclosed in square brackets enclosed in square bracket, then it is known as a matrix. Then it is known as a matrix. It is known as a matrix. Now, to understand matrix, we have to understand, let's take an example. So if I say, for example, 2 5 9 4 3, or let's say 6 6. So if I say this, can we say, so how many rows? This is row number 1, and this is row number 2. So we have two rows and three columns. So this is row number 1, row number 2, this is column 1, column 2, column 3. So I can say it is a 2 by 3 matrix where it has two rows and three columns. So this is how we represent a matrix, my friends. This is a matrix. Now, to understand more on the matrix, we have to understand a few nomenclature. So let's discuss them. So we have something known as scalar, we have something known as vector, and then we have something known as matrix. So let's understand the difference between them. What is a scalar, what is a vector, and what is a matrix? Now, first of all, if I say scalar, any number, any real number is a scalar value, is a scalar value. Now, if I say, for example, we can say 5, it is a scalar. We can say 7, it is a scalar. I can say minus 4, it is a scalar. We can say 2.8, etc., etc. So these are the scalar values. So how many scalars we have here? 1, 2, 3, 4. Four total, four scalars we have. So all are the examples of real numbers. So any real number is a scalar value. Generally, scalar value represents the magnitude. Now the second thing that we have is the vector. So we can say it is a combination of the scalars, we can say. So it represents multiple scalar. You can say one more thing I want to discuss here. A scalar, a scalar represents the magnitude only. Now, magnitude means the value only. Now, if I talk about the vector, what is a vector? So a vector is something, a vector is something that has the magnitude as well as the direction. Once we have the combination of both, then we call it as a vector. So for example, we can say weight. So weight, let's say 2.5 kg of something, we have the weight of 2.5 kg. So here 2.5 kilogram, we can say, is the magnitude, and the gravity also we have here. So gravity, you can say, that is giving us the direction. So direction, it is representing the direction. So that is why it is the, we can say it is a scalar, sorry, it is a vector. It is a vector that represents. This is the definition that we generally use in the physics. Now, what is the use of a vector in when it comes to data, or in machine learning? So a vector represents a row or a column in data. A vector represents a row or a column in a table. Let's say I have some tabular data. So in that case, I can say, so how do we say? Let's say I have some data. Let's take an example. I have age column. I have income column. I have, let's say, gender column. I have education column like this. And then what do? We have some values here. Let's say 28 and 5, gender is 1, education is 0. Let's say I'm representing everything using numbers. We will see later on how to represent. So here I have maybe 35, here I am saying 4, here I am saying maybe 0, here I am saying maybe 1, like this. So here if I take only these values, if I take only one row, this is the row number 1, this is the row number 2. So if I take only one row, 28, 5, 1 and 0, so I will represent it like this: 21, 5, 1 and 0, and I can say it is a row vector. It is a row vector. It is a vector that is representing one row. That is representing one row. If I extract the second row, let's say 35, 4, 0 and 1, we can say it is also a row vector and it is representing the second row. The same way, if I extract any column, let's say I extract the age column, so I will be getting the values like this: 28 and 35. So I will be saying it is a column vector. It is a column vector. Yes. Now the same way, if I extract the income column, so we will be having 5 and 4. So if I say the income column, so we will be having 5 and 4 like this. So it is again a column vector. Column vector. So if I say this particular vector, how many scalars it has? So it has two scalars. 5 is a scalar value, 5 is a scalar value, and 4 is also a scalar value. So sometimes we call say a vector is a collection of scalars. A vector is a combination or collection of scalars. We say like that also. Collection of scalars. Now, when we combine multiple vectors together, so we get a row and column combination. So we get a matrix. So a matrix is a collection of vectors. Is a collection of vectors. We can say like that also. So multiple vectors we may have in a matrix. So if I take a matrix of this particular data, so we may have 28, 5, 1, 0. So we may have 28, 5, 1, 0, and then we may have 35, 4, 0, 1. 35, 4, 0, 1. So this is nothing but a matrix. So it has two rows and four columns. Two rows and four columns. So this is nothing but a matrix. So I hope we are getting the things. What a matrix is. So matrix, what a scalar is, and what a vector is. So once we scalar is any number, and when we combine them together and in the form of a particular row or column, it gives us a vector. When we combine multiple vectors together, we get a matrix. Fine. Now the thing is, what operations we can perform. Let's move to the next part. And the next part is operations on a matrix. What operations we can perform on a matrix, guys? So here we can say matrix operations, or first of before that we can say types of matrices. Types of matrices. So we have different types of matrices. We have rectangular matrix, rectangular matrix. We have square matrix, square matrix. We have diagonal matrix, diagonal matrix. We have identity matrix, identity matrix, and we have null matrix, null matrix. Apart from that, we have the triangular matrix. We have the triangular matrix. So we are going to discuss about them one by one. So first of all, let's discuss the rectangular matrix, guys. So rectangular matrix. If I talk about the rectangular matrix, now the matrix where the rows, the number of rows are not equal, are not equal to the number of columns, to the number of columns is known as a rectangular matrix, is known as a rectangular matrix. Now let's say how to express this. I have a matrix, and the matrix, let's say it looks like this: 1 4 9, let's say 3 7 2. This is, now it is a 2 by 3 matrix. It is a 2 by 3 matrix. Now whenever we have any matrix, we say like this is the row, we represent it like this: a11, a12, a13. Here a second row first column, second row second column, and second row third column. This is the generic representation of a matrix. So a is representing the element, and this is representing the position. So 1 1 means the first row first column, first row second column, first row third column, second row first column, second row second column, and second row third column. This is the generic representation, and we say it is, let's say, m into n matrix, m by n matrix. So whenever we have the matrix of m into n shape, and where it will be a rectangular matrix if m is not equal to n. If m is not equal to n, then we can say yes, it is a rectangular matrix. Fine. So this is a rectangular matrix. If I have some matrix like this, for example, 2 1 4 5, and let's say 7 9, like this. So it is a 3 by 2 matrix, 3 by 2. So here again it follows the condition m is not equal to n, so we can say it is a rectangular matrix. It is a rectangular matrix. Now the second matrix that we have is the square matrix. The second matrix that we have is the square matrix. Now where m is equal to n, m is equal to n, then it is a square matrix. It is a square matrix. Now m is what? M is the number of rows, and n is what? N is the number of columns. So for example, I say 2 4 9 3, for example. So here we have 2 by 2 matrix. It is a 2 by 2 matrix. So here we can say m is equal to n. Then we can say yes, it is a square matrix. It is a square matrix. Fine. Now if I have a 3 by 3 matrix, for example, I create a 3 by 3 matrix. Let's say 2 4 6, maybe 5 5 1, maybe 0 8 3. Now here we can say it is a 3 by 3 matrix. So it is also following the condition m equal to n. Then yes, it is a square matrix also. So whenever we have the number of rows are equal to the number of columns, we call it as the square matrix. Fine. Now the third matrix that we have is the diagonal matrix, my friends. Diagonal matrix. Diagonal matrix, the matrix, the matrix where all the non-diagonal elements, non-diagonal elements are zeros, are zeros, then it is a diagonal matrix. Then a diagonal matrix is a square matrix as well. A diagonal matrix is a square matrix. A diagonal matrix is a square matrix as well. So to be a diagonal matrix, first of all, the matrix has to be a square matrix, and then apart from the main diagonal, apart from the main diagonal or the principal diagonal, whatever the other elements we have, those have to be zeros. Let's take one example. Let's say I have a matrix and it is a suppose 2 by 2 matrix. So here I say 1, 1, 5, and I say 0, 0 like this. So here it is a 2 by 2 matrix. So first condition is fulfilled. It is a square matrix. And then if I talk about the left to right diagonal, so this is my left to right diagonal. This is my diagonal. And apart from the diagonals, whatever elements I have, those are zeros. So it is a diagonal matrix. Now the same way, I may have the matrix like this. Let's say 2, 4, 6, 1, 1, 5, 2, 8, 9, for example. If I talk about the principal diagonal or the main diagonal, so this is the principal diagonal or the main diagonal here. Apart from this, whatever other elements I have, those have to be zeros. So still it is not a diagonal matrix. These elements, apart from the principal diagonal, whatever elements I have, all the elements have to be zeros. So now what I am doing, I am making them to be 0. So now this is nothing but a diagonal matrix. So apart from the principal diagonal, so this we call it as the principal diagonal, my friends. Principal diagonal. This is nothing but principal diagonal. Apart from the principal diagonal, whatever elements we have, those have to be 0. Then we can say it is a diagonal matrix. The next type of matrix that we have is the identity matrix. Identity matrix. Now, first of all, it is a square matrix. It is a square matrix in which the elements in which all the elements all the elements on principal diagonal all the elements on principal diagonal are ones and rest of the elements are zeros. Rest of the elements are zeros. Then this kind of then it is known as it is known as identity matrix. It is known as identity matrix. Let's take one example and let's try to understand this. Let's say I have a matrix A and it is like this. So if we observe in this particular, this is my principal diagonal and all the elements on the principal diagonal are ones. Rest of the elements that we have are zeros. So we can say A is nothing but the identity matrix. Identity matrix is represented by I, capital I. So we can say this is the identity matrix. A is nothing but it is the identity matrix I. A is nothing but it is an identity matrix. Now, if I take some matrix like this, for example, I have some matrix B and I do this 1, 0. So let's say 1, 1, and then I say 0 like this. So this will be again the identity matrix. This is also an identity matrix, guys. I hope we are making sense. So we have seen rectangular matrix, we have seen square matrix, we have seen diagonal matrix, we have seen identity matrix. Now we have the null matrix, guys. Null matrix. The matrix where all the elements all the elements are zeros, then it is a null matrix. Where all the elements are zeros, then we can say it is a null matrix. So let's say I have some matrix A and I have, let's say, like this 0, 0, 0, 0, 0, 0. Then we can say it is a null matrix. It is a null matrix. Now I have some matrix B and I say, for example, 0, 0, 0, 0. All the elements are 0, so we can say it is a null matrix. It is a null matrix. The last, the next we have is the triangular matrix. Triangular matrix. In triangular matrix, a triangular matrix is again a square matrix. It is a square matrix where if we say in such a way, in such a way, let's say, let's say I have a matrix and I in this matrix I have some principal diagonal. Sorry, my friends. Let's say I have a principal diagonal and principal diagonal is this 2 and then I have some values 2, 3, 5 and then I have 0 and I say maybe 1, 9 and I have 0, 0 and maybe I have 4 like this. Now if I talk about the principal diagonal, this is the principal diagonal, this is the principal diagonal. In this particular matrix, this will be my principal diagonal. So a triangular matrix, maybe it is a square matrix and it may be a upper triangular or the lower triangular if if all the elements all the elements below the principal diagonal below the principal diagonal are zeros, then it is a upper triangular matrix. It is an upper triangular matrix, guys. Whereas if we say all the elements, if we have the matrix in such a way, let's say the matrix I see is this 4, 0, 0, then I have 2, 2, 8, 0, then maybe 7, 1, 0 like this. In this case, in this case, if I see this is my principal diagonal, this is my principal diagonal, and if you see all these elements above the principal diagonal are zeros. If we have such a matrix, then we call it as the lower triangular matrix. So in this, if all the elements, all the elements above the principal diagonal, above the principal diagonal are zeros, then we say, then we say it is a lower triangular matrix. Lower triangular matrix. So here guys, we have tried to see what a matrix is, what a vector is, what a scalar is, and why we are using matrix. Why we are using matrix? Since the calculation, whatever my algorithm is going to perform internally, it is going to use the matrix calculations, and that is the reason. That is the reason we are using the we are learning the matrix operations, or we are learning about matrices. So matrices are the easiest way, or you can say the easier way to solve some linear equations. So our algorithms are also going to solve some linear equations using the matrix operations. That is why we are learning. So we have seen what a scalar is, matrix is, vector is, and then what type of matrices we have. In the coming session, we will see what operations we perform. So operations on a matrix, we are going to see arithmetic operation. We can perform dot product, scalar product, we call it. So those kind of operations, determinant, inverse of a matrix, cofactor of a matrix. So these operations we are going to see in the coming session.
Did you enjoy the
Thanks.
video?
Thanks,
I'm
Mike.
sure you did. And just like this, you're going to enjoy an absolutely free personalized career guidance call with our counselors for free. Call on the number below and book your slot today.